In the world of dinosaurs, the Brachiosaurus is renowned for its towering neck, which could be as long as 2 or 3 giraffes stacked on top of each other. What prompted this dinosaur to evolve such an extraordinary feature, and what made its body structure so different from other giants of its era? Was this remarkable neck merely a feeding tool, or did it serve other crucial survival purposes? To understand what made Brachiosaurus so distinctive, it helps to look closely at its anatomy. Unlike most sauropods, Brachiosaurus had front limbs that were noticeably longer than its hind limbs. This gave its body a steeply inclined profile, with shoulders rising above the hips and a trunk that sloped upward much like a giraffe. The result was a creature whose entire body seemed built for reaching higher than almost any other herbivore of its time. Interestingly, many popular images of Brachiosaurus are actually based on a closely related dinosaur, Giraffatitan, which has since been recognized as a separate genus. Still, the general body plan, a towering neck, long forelimbs, and a relatively short tail remains a defining feature for both. The neck itself was a remarkable adaptation. Composed of large, robust vertebrae and supported by a network of lightweight, air-filled bones. It formed a gentle S shape, curving back at the base, straight through the middle and forward at the top. This structure allowed Brachiosaurus to elevate its head high above the ground, accessing foliage that was out of reach for most other dinosaurs. Such a feeding strategy opened up a niche in the Jurassic forests, where tall conifers and ginkgo trees dominated the canopy. Chisel-shaped teeth let them swiftly strip high foliage, and instead of chewing, Brachiosaurus swallowed leaves whole, relying on powerful hindgut fermentation and gastroliths to break down tough plant material. Weighing an estimated 28 to 47 tons, Brachiosaurus needed to be efficient in every aspect of its biology. Its massive size not only helped deter predators like Allosaurus, but also influenced how it moved and fed. The animal's respiratory system, similar to what we see in modern birds, featured a network of air sacs that made oxygen intake more efficient, an important adaptation for such a large body. The combination of a long neck and this advanced breathing system meant Brachiosaurus could feed over a wide area without walking long distances, conserving energy that would have otherwise been spent moving its enormous frame. This efficiency extended to its digestive system as well. By stripping and swallowing large amounts of foliage quickly, Brachiosaurus could ingest enough food to sustain its bulk. The process of hindgut fermentation, aided by swallowed stones, allowed it to extract nutrients from tough plant fibers. This method was not unique to Brachiosaurus, but it was especially important for such a large animal with a high energy demand. The sheer size of Brachiosaurus also provided protection. Adult individuals stood so tall and weighed so much that few predators could pose a serious threat. While smaller or younger brachiosaurs might have been vulnerable, a fully grown adult would have presented a daunting challenge for even the largest carnivores of its era. Taken together, the anatomy of Brachiosaurus reflects a series of evolutionary solutions to the challenges of survival in the Jurassic landscape. Its long neck and sloped body allowed it to exploit a food source that few others could reach, while its size and physiology offered both protection and efficiency. Yet while the advantages of a long neck seem clear, paleontologists continue to ask whether reaching high vegetation was the only reason for this adaptation, or if there might be other factors at play. Was the long neck of Brachiosaurus only about reaching food, or was there more to the story? At first glance, the neck seems like an obvious tool for obtaining vegetation in the highest canopies, far out of reach for other herbivores. Its towering height allowed Brachiosaurus to take advantage of resources that many competitors simply couldn't access. This gave it a significant edge in the lush, plant-filled world of the Jurassic. But as more has been uncovered about this dinosaur's anatomy, scientists began to wonder, could the neck have served other purposes beyond just mealtime efficiency? The traditional view of the neck as a feeding adaptation isn't wrong. Its tremendous length enabled Brachiosaurus to graze across large vertical feeding zones without much effort. Biomechanical studies suggest this feature wasn't just about reaching high foliage, it also saved the animal energy. Rather than moving its colossal body to find new vegetation, Brachiosaurus could cover a wide range simply by sweeping its neck. This energy conservation was essential for such a massive creature that required enormous amounts of food to survive. Additionally, the neck's range of motion provided access to vegetation both above and at intermediary levels, ensuring that the dinosaur made the most of its environment without expending unnecessary effort. Yet there are theories that the neck wasn't purely utilitarian. Its role might have extended beyond feeding. For instance, the neck may have been a key player in body temperature regulation. With such a massive size, overheating posed a major threat to Brachiosaurus. Some paleontologists suggest the long neck stretched away from the body could have acted as a heat-dissipating surface, helping the dinosaur to cool off. This theory remains speculative, but adds an intriguing layer to its potential functionality. Another possibility is tied to social interaction. Some scientists hypothesize that the neck may have been used as a display feature, much like peacock's tails or antelope horns today. A larger, longer neck could have signaled strength or genetic fitness, helping to attract mates or intimidate rivals. This idea gains support when we observe modern animals like giraffes, which use their necks during courtship or combat. Similarly, Brachiosaurus might have used its neck as a signal of dominance within its social structure, showcasing its physical advantages in ways beyond feeding. This long-necked adaptation also presented incredible physiological challenges, particularly in its cardiovascular system. A neck that stretched so far above the body required immense blood pressure to pump oxygen-rich blood to its brain. Scientists estimate that Brachiosaurus's heart had to operate at double the pressure of a giraffe's, already one of the highest among modern animals. Such an intense cardiovascular requirement highlights how specialized the anatomy of Brachiosaurus truly was. The dinosaur's heart vascular pathways and overall circulatory system were essential in supporting the immense height that set it apart from other herbivores of its time. Looking to modern examples like the giraffe helps us better understand the complexity of these adaptations. Giraffes, much like Brachiosaurus, rely on their long necks for feeding, but they also use them for thermoregulation, observation, and display. By studying how their anatomy functions, we gain clues about how dinosaurs may have utilized similar features. This comparative approach gives paleontologists a broader context for interpreting the potential uses of Brachiosaurus' towering neck beyond the limitations of fossil evidence. While we may never know every reason behind Brachiosaurus' incredible neck, it's clear that this evolutionary masterpiece served more than one purpose. From maximizing feeding opportunities to aiding in social interaction or even regulating temperature, the long neck provided a range of survival benefits, ensuring this dinosaur's success in its prehistoric world. And yet, while we've unraveled some of its mysteries, there's still one long-standing misconception about this dinosaur's life that needs correcting. For years, scientists thought Brachiosaurus lived in water to support its massive weight, but they were wrong. Did Brachiosaurus really live in water to support its massive weight? Early scientists thought so, but they were wrong. Let's take a closer look at this theory, how it came about, and why researchers now agree that Brachiosaurus was a land-dwelling giant. The idea that Brachiosaurus was semi-aquatic originated in the early 20th century. At the time, paleontologists observed two key features of its anatomy that seemed to suggest a life spent partially in water. First was the placement of its nostrils. These were positioned high up on its head near its eyes, which seemed similar to modern aquatic animals like hippos, who use elevated nostrils to breathe while submerged. Second was its immense size. Early researchers questioned how such a massive creature could support its own weight on land, and theorized that the buoyancy of water would have made movement easier. With limited fossils available in those early days, this interpretation appeared to make sense. This semi-aquatic theory shaped much of the early understanding of Brachiosaurus. Scientists envisioned it wading through deep lakes or slow-moving rivers, using its long neck to graze on submerged vegetation or low-hanging branches near the water's edge. The mental image of a dinosaur moving gracefully through murky wetlands became so popular that it was depicted this way in many illustrations and even early museum exhibits. However, as more evidence came to light, this view began to break down. One major problem with the aquatic hypothesis was the extreme water pressure that would have affected Brachiosaurus's ability to breathe. To fully submerge a creature of such immense size, the water pressure on its chest and lungs would have been enormous. Breathing under those conditions would have required adaptations that Brachiosaurus simply didn't have. These physiological constraints directly contradicted the idea of a semi-aquatic lifestyle. Instead, they suggested Brachiosaurus was far better suited to life on land, where it wouldn't face such challenges. Another discovery that helped debunk the aquatic theory was evidence of terrestrial footprints. Fossilized tracks belonging to sauropods, including relatives of Brachiosaurus, were consistently found on solid ground, not in the soft sediments associated with underwater environments. These tracks clearly showed that Brachiosaurus and similar dinosaurs walked on dry land, further weakening the argument that they spent much time in water. The shape, spacing, and patterns of the footprints left no doubt that Brachiosaurus was an active terrestrial animal capable of bearing its weight. Advances in the study of Brachiosaurus's skeleton also played a critical role in overturning this misconception. Its bone structure told a story far more suited to land than water. Aquatic animals tend to have dense, heavy bones to help them stay submerged, but Brachiosaurus had lighter, air-filled bones, especially in its vertebrae, which would have made floating difficult. Its front legs, which were significantly longer than its hind legs, created a sloped body perfectly built for feeding high up in trees rather than swimming or wading. This limb structure supported its terrestrial lifestyle, keeping it balanced and efficient while foraging on land. The environment where Brachiosaurus lived added another layer of context. The Morrison Formation, a rich fossil deposit from the late Jurassic period, paints a picture of a lush landscape filled with rivers, floodplains, and abundant vegetation. This ecosystem had everything a land-dwelling herbivore required, from towering trees to seasonal water sources. It offered plenty of opportunities for Brachiosaurus to thrive without needing to adopt an aquatic lifestyle. Furthermore, the presence of other sauropods, each adapted to different feeding levels, indicates an ecosystem finely tuned for terrestrial coexistence. This shift in understanding from viewing Brachiosaurus as semi-aquatic to fully terrestrial reflects the nature of science itself. Early conclusions were drawn based on limited evidence as researchers worked with the fossils and comparative data available at the time. As new discoveries emerged, from more complete skeletons to fossilized tracks, the pieces came together to reveal a creature designed for life on land. This process highlights how scientific knowledge evolves, driven by new findings and advanced techniques. Brachiosaurus, once imagined trudging through deep water, is now celebrated as a land-dwelling titan. It dominated its environment not by floating, but by towering over its herbivorous competitors. More than just a correction of an outdated idea, this evolution in our understanding reminds us how much there is yet to learn about the prehistoric world, and how much our interpretations can still change with new discoveries. What can this teach us about the way we study prehistoric life? Lessons like this show that even giant fossils require a giant leap of imagination and a lot of evidence. Through Brachiosaurus, we see nature's engineering at its best. Its long neck, high shoulders, and massive size are the result of evolutionary pressures that shaped one of the most distinctive dinosaurs we know. Each new fossil and research method has changed how we understand its life, from feeding high in the Jurassic canopy to moving confidently across ancient floodplains. Brachiosaurus teaches us that every fossil holds surprises. What will the next find reveal? Tell us which dino mystery you want solved next in the comments. Thanks for watching, and stay curious as we keep exploring the fascinating history of life on Earth.